Okay, let's go over, this is on section 1.3b. I want to look at the domain and range of R of x and S of x. Okay, so let's first talk about domain, since in this case that's the easier to speak about. So if we're looking at domain, the only issue I have is there's an x in the denominator. So I want to see, and I can't divide by 0. So is it possible for the denominator to equal 0? And in this case, the answer is no, because you can't square something and get a negative number, which means I can plug in anything for the domain. So the domain is all reals. So then when we think about the range, we're thinking about output. What are the possible outputs of this function? And so if we look at the function, 4 is just going to stay as 4. The only thing changing is that x squared. And the smallest that's going to be is 0. And then it can get hugely positive. And I have this plus 9. So for the range then, I'm dealing with, if we would look at, you do the order of operations for the denominator. The numerator is 4. The denominator will range from 9 to infinity. Okay, so, well, what does this mean in terms of what can be output? What's the output of this fraction? What possible values? Well, we know it can't be negative because everything, numerator is always positive, denominator is always positive. So then we just want to really check the extremes. Can it go, can't be 0 because the only way it's 0 is if the numerator is 0. So I want to check, can it get really close to 0 from the positive side? And can it also explode towards positive infinity? Okay, so let's test this. To get close to 0, I would have to have my number 4 be divided by an enormous number. And I have that. 4 divided by infinity is going to get super close to 0 from the positive side. So that's going to happen. Never going to hit 0, though. And in terms of will it ever explode towards positive infinity? Well, if the numerator's 4, the only way that could happen is if I divide 4 by a tiny positive number. Then that'll explode towards infinity. Well, I don't have tiny positives on the denominator. All I have is the smallest number I have is 9, which is going to mean that, this should be a parentheses, which is going to mean that the biggest this is going to be is certainly not infinity or approaching infinity. Instead, the biggest will be 4/9. Okay, so that was R of x. The domain was all reals, and the range is 0 to 4/9 inclusive. All right, let's look at another one here. Let's look at S. Okay, so again, to look at the domain, I just have the variable in the denominator, so I want to see, is this ever going to be equal to 0? And once again, I've got a squared value, and that if I try to solve this, I can't have something squared equaling negative. So it's never going to be 0, so I don't have to worry in terms of something that it can't be. So the domain is all reals. Now for the range. We're going to do the same process that we did for R. So for the range, the numerator, and let me just do a little line here. The numerator is -2. The denominator, the only thing that's changing is the x minus 3 squared. So the smallest that can be would be 0, and it can explode to infinity, and then I have the plus 7. So what I'm really dealing with here is I've got -2 over 7 to infinity. Okay, so let's think about this for a second, because unlike the previous problem, in this case, the numerator is negative. And if I have a negative divided by all positive values, my output is only going to be negatives here. So I want to see, like I did in the previous example, instead of seeing if it hits the positive extremes, I want to see if it hits the negative extremes. So is it going to explode towards negative infinity? And is it going to get close to 0 from the negative side? Okay, so the only way it explodes towards negative infinity is if I had -2 over tiny positives. I do not have that. Instead, I have the smallest I have in the denominator is 7. So it's not going to go towards negative infinity. In fact, the most negative it will go is -2 7s. Now, in terms of will it go towards 0 from the negative side, to do that, I need to divide my -2 by a huge positive, because that'll bring it close to 0, and I have that. I have infinity in the denominator. So, and it's never going to hit 0, right, because the only way a fraction is 0 is if the numerator is 0. So that's my range in that case. So those are two kind of tricky problems. But in these cases, when you have a number in the numerator and some sort of variable expression in the denominator, you really want to check to see, is it hitting your extremes? And that should help you get towards the range. So in this, because of the nature of R of x, I knew it right away looking at this expression here that I didn't have to worry about the negatives. Similarly, with S of x, I knew because of this expression here, or this fraction here, that I didn't have to look at the positives. But sometimes you will have to look at all four extremes. Okay, that's it.